science lang lang ako eh.
Ha?
Hindi ko alam na may crack na pala yung bike ko.
Naku po, delikado yan. Ano nangyari?
Estimate lang, hindi ko alam paano ko rin kasi kung makikita kung may crack na eh.
Alam mo ba, meron akong dating nalaman na parang meron silang mga test na ginagawa para sa mga may crack na bakal.
Oo, saan yan?
Napanood ko lang siya sa YouTube eh. Mahanap ko pa yun sa history. Tara, panoorin natin.
Ah, sige, sige.
Magnetic detection testing.
Good day everyone. I am now discussing the magnetic particle testing. The basic principle of magnetic particle testing has a relatively simple concept.
For the case of a bar magnet, the magnetic field is in and around the magnet. Any place that a magnetic line of force exits and enters the magnet is called a pole. It is a magnetic line of force exit the magnet from north pole and enter from the south pole. If the magnet is cracked but not broken completely in two, a north and south pole will form at each edge of the crack. The magnetic field exits the north pole and re-enters at the south pole.
Magnetic particle testing is one of the most widely utilized non-destructive testing methods since it is fast and relatively easy to apply. This method uses magnetic field and small magnetic particles, or for example the ion filings, to detect rusting component. The only requirements from an inspectability standpoint is that the component being inspected must be made of ferromagnetic materials. A ferromagnetic materials is a material that can be magnetized, such as iron, nickel, cobalt, or some of their alloys. Magnetic particle testing is used to inspect a variety of product forms, including casting, forging, and weldments. Many different industries use magnetic particle testing such as structural steel, automotive, petrochemical, power generation, and aerospace industries. Underwater inspection is another area where magnetic particle testing may be used to test items such as offshore structures and underwater pipelines. The advantages of using magnetic particle testing compared to other non-destructive testing methods are: first, high sensitivity. As small discontinuities can be detected. Second, indications are produced directly on the surface of the part and constitute a visual representation of the flaw. The third, minimal surface preparation. No need for the paint removal, for example. And the fourth one is portable. Small portable equipments and materials available in spray cans. And the disadvantages of using magnetic particle testing method is only surface and near surface defects can be detected. Only applicable to ferromagnetic materials. Relatively small area can be inspected at a time.
Three types of magnetizing current.
Good day everyone, I'm Mayabeth Urbisono and I will be discussing the three types of magnetizing current. So for now, we have the first part, which is the direct current, The next one is the alternating current, and the last one is the rectified alternating current. So we have now the first type, which is the direct current. So the first type of magnetizing current is the direct current. So the direct current flows continuously in one direction at a constant voltage. The most common example of a DC voltage is a battery. So the current is said to flow from one terminal, which is the positive, up to the negative terminal. Direct current is very desirable when inspecting for subsurface defects because of the DC generates a magnetic field that penetrates deeper into the material. In ferromagnetic materials, the magnetic field produced by direct current generally generates the entire cross-section of the component. So for now, we have the second type of magnetizing current, which is the alternating current. So an alternating current reverses its direction at a rate of 50 or 60 cycles per second. So since alternating current is readily available in most facilities because of its convenience, that is generally generated and transmitted by certain companies, it is convenient to make use of it for magnetic particle inspection. However, when an alternating current is induced to a magnetic field into ferromagnetic materials, the magnetic field will be limited to a thin layer at the surface of the component. This phenomenon is called a skin effect that is heavily affected by eddy currents in the test object. So, for us to understand what a skin effect and eddy currents are, we will watch this video.
The magnetic particle examination method may be applied to detect cracks and other discontinuities on or near the surfaces of a given material. Satisfactory results are usually obtained with surfaces as welded, rolled, casted, or forged conditions. Yoke should have a valid calibration in which the lifting power is checked. A yoke is an equipment used to help carry or pull heavy objects by distributing the weight evenly on both shoulders or sides. In this video, AC and DC yokes are used. Before testing begins, it is recommended to check the overall performance before the procedure. For this, a flux indicator can be used. Cleaning techniques are used for the surfaces at least 25 mm around the weld or area to be inspected, and it should be free from oil, grease, scale, and other liquids. White paint is mostly used, and a contrast enhancer applied to the flux indicator. Most important that the part is being magnetized while the particles are still airborne and free to leakage. Each area should always be examined at least twice. The pole spacing to be between a minimum of 3 inches and a maximum of 10 inches. Inspections are visible to the surface, which irregularities are shown. Size, intensity, amount are given. Post-examination is required after each procedures.
Now, the third type of magnetizing current is the rectified alternating current. So, the skin effect limits the use of alternating current since many inspection applications call for the detection of the surface defects. Luckily, alternating current can be converted to the current that is very much like DC or direct current through the process of rectification. With the use of rectifiers, devices that can be rectified, the reversing alternating current can be converted to a one-directional current. The three commonly used types of rectified currents are the half-wave rectified current, the full-wave rectified alternating current, and the three-phase full-wave rectified alternating current. And for the second part of my discussion, I will explain the magnetization equipment for magnetic particle testing. So, one portable equipment in the process of inspecting is the permanent magnet. So, permanent magnets can be used for magnetic particle inspection as the source of magnetism. Some examples are the bar magnets or horseshoe magnets. The use of industrial magnets is not popular because they are very strong and thus they are difficult and sometimes dangerous to handle. However, permanent magnets are sometimes used by drivers for inspection in underwater environments or other areas such as explosive environments where electromagnets can be used. Permanent magnets can also be made small enough to fit into tight areas where electromagnets might not fit. So, the second equipment I will be discussing is the electromagnetic yokes. So, this yoke is a very common piece of equipment that is used to establish a magnetic field. A switch is included in the electrical circuit so that the current and therefore the magnetic field can be turned on and off. They can be powered with alternating current from a wall socket or by a direct current from a battery pack. This type of magnet generates a very strong magnetic field in a local area where the poles of the magnet touch the part being inspected. Some yokes can lift weight in excess of 42 pounds. And the next equipment to be used are the prods. So prods are handheld electrodes that are pressed against the surface of the component being inspected to make contact for passing electrical current, either DC or AC, through the metal. Prods are typically made from the copper and have an insulated handle to help protect the operator. One of the prods has a trigger switch so that the current can be quickly and easily turned on or off. And the last two equipment to be used in inspection are the portable coils and conductive cables and the portable power supplies. So the portable coils and conductive cables are used to establish a longitudinal magnetic field within the component. When performed coil is used, the component is placed against the surface of the coil. Coils typically have their 3 or 5 turns of a copper cable within the molded frame. A foot switch is often used to energize the coil. And when it comes to the portable power supplies, these supplies are used to provide the necessary electricity for the prods, coils, or cables. Power supplies are commercially available in a variety of sizes. Small power supplies generally provide up to 1,500 amperes or half-wave DC or AC. They are small and light enough to be carried and operate on either 120 volts or 240 volts electrical service.
Magnetic particles.
Good day, everybody. Everything, every day. I'm Jasingal J. Manalak, BSEE4 from Maragondon branch. I'm here to discuss the magnetic particles. Magnetic particles. The particles that are used for magnetic particle inspection are key ingredients as they form the indication that alert the inspector to the presence of defect. As mentioned previously, magnetic particles or iron filings is a key ingredient in this testing, because every single company or product, there's a things that called ingredients that help the people to easily recognize such a thing or such a problem. To overcome it, a pigment, something like paint, is bounded to the surface to give the particles color. The metal used for the particle has a high magnetic permeability and low retentivity. What is high magnetic permeability? It is the measure of magnetization that a materials obtain in response to applied magnetic field. It is important because it makes the material attract easily to a small magnetic leakage field to continue the flows. Low retentivity means it's become more weak magnet when the current is turned off, ideally zero retentivity. It is important too because the particles themselves never become strongly magnetized, so they do not stick to each surface of the part. Magnetic particles are available in a dry mix or wet solution. Now, first, I will discuss the dry magnetic particles.
Dry magnetic particles.
Dry magnetic particles is typically purchased in red, blue, yellow, and green, and other several colors, so that the high level of contrast between the particles and the part being inspected can be achieved. Magnetic particles product are also produced the range of particle sizes. The fine particles have a diameter about 50 micrometer to 150 micrometer. The particles more times lighter than the coarse particle to make sure this particle can feel the magnetic leakage field. Additionally, small particles easily adhere to surface contamination such as moisture and get trapped to the surface roughness. Features and these particles will be more easily blown away by the wind. First thing to do is clean the surface to avoid roughness and remnant dirt. An isolated area is the best place to perform this testing to maintain the iron filing in a surface. And last, mix of rounded and elongated particles is used to maintain good sensitivity. And now, I will discuss wet magnetic particles. The wet magnetic particle testing method is generally more sensitive than dry magnetic particles because wet magnetic particles is more mobility and make it possible for smaller particles. The particles are typically 10 micrometer or smaller. These wet magnetic particles is both visible and fluorescent particles are available. Fluorescent particles are coated with pigment that can see when the surface exposed to the ultraviolet light. Additionally, both visible and fluorescent wet suspended particles are available in aerosol spray cans for increased portability of application. Now, I will discuss the dry particle inspection. Dry particle inspection. In these magnetic particle testing techniques, dry particles are dusted into the surface of the test object as the item is magnetized. Dry particle inspection is well suited for the inspection conducted on rough surfaces. When electromagnetic yoke is used, the AC current creates a pulsating magnetic field that provides mobility to the powder. Dry particle inspection is also used to detect shallow subsurfaces, cracks. Dry particles with half-wave DC is the best approach when inspecting for the lack of root penetration in welds of thin materials. To understand more about dry particle testing, Here's some video.
So what we're going to do is we're going to demonstrate the proper technique to perform magnetic particle testing through a layer of paint on a component. Typical applications from ASTM E709 is a particular standard that we're working to, the American Standard Testing of Materials, and it doesn't allow you to test through paint. You need to test through uncoated surfaces. You're allowed 1 or 2 mils of paint, and then that would be acceptable. But if it's a special application like this particular component has about 16 mils of paint on it. So in order to test through this, you need to be able to demonstrate that you can find the particular anomalies that you're looking for and demonstrate the technique. So this is a magnetic particle yoke. We're going to start over here. One of the things that we teach our technicians is the proper technique to applying the particles. As you apply the particles, you want to actually just float them on. You don't want to dump them on with a can such as that. You just want to be able to lightly float the particles on. And the same thing with a puffer. When you blow the particles away, you want to be a little tender and a little sensitive and make sure that you have the right technique. We're going to move down across the plate, making sure that we have overlap. So I make sure that I test 100% of this particular component. I don't see anything there. I'm going to move down again. And as I apply this here, we actually start to see the formation of an indication along the toe of the weld. That happens to be about a 2-inch long crack in the heat affected zone. So as I talked about before, that it's important to know the techniques and the proper technique of blowing the particles off, because if I use too much force, especially on a painted plate as opposed to an unpainted plate, I can actually blow the particles away and you no longer see the crack. So again, it's important to have the proper technique in floating the particles on and watching them form, and then also the proper particle removal with the blower.
Now, I will discuss the step for performing dry particle inspection. Surface preparation. The surface must be free of grease, oil, or other moisture that could keep particles from moving freely. Any loose, dirt, paint, rust, or scale must be removed. Applying the magnetizing force. Use permanent magnet, electromagnetic yoke, coil, prod, or other means to establish the necessary magnetic flux. Applying dry magnetic particles, it is a dust on a light layer of magnetic particles. Blowing of excess powder with the magnetizing forces still applied, remove the excess powder from the surface with a few gentle puffs of a dry air. The forces are need to be strong enough to remove the excess of particle, but not strong to remove particles held by a magnetic flux leakage field. Last, inspection for indication. Look for the area where the magnetic particles are clustered. And that's it. My group, I truly appreciate your listening. It's been a pleasure to report this kind of topic.
Contando, rezando que seas lo que ando buscando.